Donc, merci à tout le monde d'être ici. Les gens qui sont ici en personne, malgré les difficultés de se déplacer, et puis tous les gens qui sont à la maison. Alors, combien de personnes? 25? À peu près 25 personnes à la maison. Donc, bienvenue à tout le monde. Euh, euh, Panglache à Ni Hao, Huan Ying Wale. Donc, bienvenue à tout le monde. Et puis, ce que je vais faire, c'est que je vais présenter un peu les activités de l'Institut qui s'en viennent, très brièvement.
Allez.
La parole à... Muter les gens. Euh, je vais céder la parole ensuite à Anis Boubacar, qui a invité et puis travaille en collaboration avec Ying Fang pour la santé. Et par la suite, la professeure Fang va faire sa présentation. Donc, prochainement, à l'Institut des sciences cognitives, il va y avoir trois activités que je vais vous annoncer. Donc, le 12 mars, il va y avoir la suite de nos MIDIA, où est-ce que je vais présenter les MIDIA, c'est comme des espèces de petits ateliers du midi, où est-ce que je présente certains thèmes sur l'intelligence artificielle, des fois des thèmes plus pratico-pratiques, des fois plus techniques. J'essaie d'alterner entre les deux. Et la prochaine fois, c'est sur ce qu'on appelle maintenant les reasoning models, donc les large language models qu'on réentraîne avec du reinforcement learning pour avoir des meilleures traces pour être capable de réfléchir. Donc, donc, je vais présenter un petit peu qu'est-ce qu'il y en est à cette midi-là. La semaine suivante, donc le 13 mars, on aura, donc la même semaine, en fait, le 13 mars, le lendemain, on a notre journée inter-institut, où est-ce que, qui va porter sur le thème, donc savoir et participation citoyenne face à un monde complexe en transformation. Et donc, chaque institut va présenter de sa perspective cette question-là. Et nous, de l'Institut des sciences cognitives, on a invité Bruno Dubuc, donc, qui est l'auteur du livre à succès, on peut dire maintenant, Le cerveau à tous les niveaux, dont le sous-titre est Du Big Bang à la conscience sociale. Donc, où est-ce qu'on va s'entretenir avec lui sur comment les connaissances en sciences cognitives permettent ben, de mieux s'engager dans le monde, d'avoir une meilleure participation citoyenne, etc. Donc, ça, vraiment une tentative de mélanger les deux thèmes. Et finalement, le 25 mars, co-présenté avec l'Institut des santé société, on va avoir une activité, donc
Ici,
une conférence,
ici.
une conférence
Parce
qui
que
s'appelle...
j'ai passé un message, j'ai juste oublié, ça fait au moins 4-5 jours que j'ai écrit pour lui. Il m'a pas lu. Mais s'il y a un problème, elle est connectée, on peut lui envoyer le message.
Euh, donc, la conférence de la semaine suivante, c'est Quantum 101. Donc, c'est présenté par Christophe Parr, qui est directeur ici au Québec de l'Institut, directeur scientifique de PIC2, qui est un institut basé à Sherbrooke qui travaille sur le développement d'ordinateurs quantiques ou l'utilisation d'ordinateurs quantiques pour faire du machine learning. Donc, c'est notre dernière conférence du mois de mars, donc co-présentée avec l'ISS. Donc, sans plus tarder, je vais laisser la parole à Anis pour qu'il présente notre conférencière d'aujourd'hui.
Merci Pierre. Je vais commencer par me présenter parce que je pense qu'on ne peut pas beaucoup ici non plus. Anis Boubacar, donc je suis professeur enseignant à l'ETS, au département des enseignements généraux. Je travaille essentiellement, en fait, dans une ancienne vie, je travaillais surtout en génie logiciel. J'ai switché vers l'AIED là, maintenant 3-4 ans. Et justement, dans le cadre de mes nouvelles activités, j'ai rencontré la professeure Ying Fang dans une conférence à IED. Et donc, ça fait un bon bout de temps qu'on travaille ensemble sur différents projets actuels et à venir. Et donc, je vais commencer par présenter Yin. Donc, Yin, j'ai pris quelques notes. Donc, elle est professeure à l'université CCNU, donc Central China Normal University. Donc, elle s'intéresse à l'analytique des données éducatives et l'intelligence artificielle en éducation. Elle est ici dans le cadre d'une invitation de l'ETS pour mener des travaux de recherche ensemble et donc donner différentes conférences dans celle-ci. Elle détient un doctorat en psychologie expérimentale de l'Université de Memphis et une maîtrise en éducation et une maîtrise en psychologie cognitive, ainsi que diverses certifications en sciences des données et en sciences cognitives. Son doctorat a été sous la supervision de Arthur Gracer. Pour ceux qui ne connaissent pas, en fait, dans le domaine de l'AIED, c'est une sommité. Elle a fait également un postdoc à l'Université de l'Arizona State sous la supervision de Daniel McManara, donc encore une fois, quelqu'un de très connu dans notre domaine. Et ses travaux portent notamment sur le développement des systèmes de tutorat intelligents dans divers contextes tels que l'enseignement des langues, des mathématiques ou de la programmation. Elle travaille aussi sur le design de jeux sérieux en enseignement et les expériences usagées associées et sur l'intégration des outils d'intelligence artificielle générative en éducation. Je pense que la présentation d'aujourd'hui va durer à peu près 45 minutes, 45 minutes, am I right?
Le temps.
You talk, it will be about 40 minutes. Sans plus tarder, je cède la parole à Ying. The floor is yours.
Bonjour tout le monde. Je m'appelle Ying. Le sujet de mon présentation aujourd'hui est Advancing Education through Big Data, Integrating Cutting-Edge Technologies and the Personalized Learning System. Désolé, mon français est limité. Therefore, I have to switch to English from now on. Please bear with me. And just now, Pierre impressed me with his Chinese.
No impressive.
So I try to speak a little bit French, and I'm just a beginner. Yeah. So the talk, how to move on to just slide.
Just gonna go back to so you can just switch, or you can click
yeah,
also. Absolutely. It's either or. You click or you use the arrows.
Yes. Oh, it doesn't work.
Click on the screen.
Click on the screen.
Okay, that's good.
The talk I'm gonna give today include 5 sections. So in part 1 and 2, I will briefly introduce our institute. I will give an overview of our institute and introduce a little bit of the research and applications that has been conducted in our institute. And then in part 3 to 5, I will switch to my own research, which will cover intelligent tutoring systems, educational games, and the application of generative AI in instruction. So first, the overview of our institute, which is called NERC EBD. So NERC EBD, here, can I move that?
You can absolutely move it with your Go ahead.
Represent the National Engineering Research Center of Educational Big Data. So it's a national level research platform specializing in research and in innovation in the application of big data in education. And here there are some pictures showing our institute. The institute is located in CCNU, which stands for Central China Normal University. And then it includes the big data storage and computing center, several research labs, the exhibition hall, and then the experimental and application demonstrating area include 60 smart classrooms. And here it shows the structure of our research center. So we have different, of our institute, we have different research centers. The research from those research centers are applied in the application forms, in a variety of application forms. And these application platforms, they generate a lot of data. The data goes to the data storage. And meanwhile, the data is computed and analyzed. And then the results of the analysis in return support the function and the improvement of the application of those platforms. And meanwhile, those platforms generate more data, which further support our research. So that's an overview, very brief overview of our research center. Now I'm going to talk a little bit about the research and applications in the institute. So we have different research direction. The first direction is about data collection, specifically multimodal data collection, because with modern technology applied in education, and right now we have more ways to collect the data from different modality. And recently, say in CCNU, we have installed sensors and cameras in our smart classrooms. And then for different research lab, we purchased a lot of equipment. And meanwhile, we developed or purchased the educational software so that we can collect a variety of multimodal data, such as like the eye tracking data, the EEG data, the physics data, and also like the learning logs recorded by those softwares. So the first research direction is related to the data collection. And then after data collection, the second research direction is about how to collect, process, and share the data reasonably and especially ethically. So when our research center was founded in 2017, this research area actually is quite new. This field is a new field. So at that time, there were not established regulations regarding how to do these things ethically. So some of our colleagues, they focus on developing the standards or the criterion about how to collect, process, and share data ethically and reasonably. And the standards and criteria that has been developed support the building, becomes like the foundation of the related systems. For example, in CCNU, there's one system that's called Xiaoya. It's widely used by all the faculty members and staff members. So every day it's like thousands of people use this system simultaneously. So a large amount of data is generated every day and stored in the system. However, for us, if we want to get access to the data, we need to fill out some paperwork to specify what data we want, why we want it, and how we are gonna use it. So how to anonymize or encrypt the data. And then the paperwork will go through the review of the IRB. Yeah, the institutional review, the board, to see whether you would do things correctly. And when it's approved, we can get access to the data that we want. Yeah. So this is the second research direction about data collection process and sharing. And then after harvesting the data, the next research direction is comprehensive modeling and learning analytics. We get the data and then how to analyze the data. So there's my colleagues, including me, we focus on analyzing the data, try to analyze different aspects of student learning, so that with the results of our analysis, we support the system, so that the system will provide better service to students and also assist the instruction of the teachers who use those systems. And then the fourth direction is intelligent management and policy making. This is mainly to help the people, the government, to make the decisions. For example, we developed this evaluation of digital, how to evaluate the criteria regarding how to evaluate the digitalization of campus. And then we came up with 5 dimensions, including infrastructure, digital resources, digital management, instruction, application, and a supporting mechanism. And then the level of and then to evaluate the level of digitalization of campus from those 5 dimensions. And then the other one is a poverty alleviation model. We came up with this model, and then the government used this model to evaluate the poverty, the educational poverty in different areas of China. And then they decide how to allocate the resources to help the underdeveloped areas. And then The fifth direction is the development, the design, development, and evaluation of intelligent systems. We came up, it's like for the systems, we need to decide how to build the system, came up with the theories, core theories of building those intelligent systems. For example, when it comes to intelligent tutoring system, I will mention it later today. There are 4 major components, how to build them properly, and then to support the application, the eventually application of building those systems. So at the bottom, in the middle picture, the intelligent tutoring system, at the bottom row, the middle one, that is a system built by our team. It is a system we built to help college students learn advanced mathematics. So advanced math is usually regarded as one of the most difficult subjects by Chinese college students. And then it inspired us to build this system to help the students. But the development of the systems are based on those theories on how to build the domain model, how to build the student model, track the students' progress, and then how to interact with college students. So all those theories are built in. We build the system based on those theories. And then the last picture, the bottom row, at the very right, intelligent intervention system for children with autism. It is developed by another team in our institute. So it was to help the children with autism. So the system can not only diagnose, but also provide intervention for the students with autism. In this system, they implement the well-established survey, and also they carefully designed the games for the kids, so that they can provide diagnosis and then help them. Provide intervention. So in addition to various different systems, the technology has also directly been used in the course instruction. And here is the demo of one course that is called Aerobics Teaching and Training. Here we can see the teaching model is practice plus technology-supported discussion. And mainly the VR is used to capture, to collect, analyze, and present the students' data. And then through discussion with the help of this technology, the instructors discuss and analyze students' motions to help them master the skills more effectively. Yes, this is a demo of the course. And then another course is called Fundamental Principles of Marxism. This course is one of the general ed courses, like every Chinese students have to take, but is usually regarded as boring. So how to engage the students, and then the lecturer apparently use the technology to help. So here the metaverse is used. Here we can see the lecturer use the technology, including 3D reconstruction, virtual reality, etc., to engage the students. In this way, the course is less boring, more engaging. Okay, so that's a brief introduction of the research and applications that has been conducted in our institute. Now I'm going to switch to my own research in intelligent tutoring systems, which are often regarded as ITS. So I'm not sure whether everyone is familiar with intelligent tutoring system or not. Or probably just the wording is not that familiar, right? So intelligent tutoring system refers to the computer-based learning environments that use AI to provide personalized instruction and feedback to learners. So all the ITS try to provide personalized or individualized instruction to different learners. And then usually there are four major components for ITS. The domain model represent the knowledge that is to be taught to the students, including the main concepts, the rules, the relation between the concepts, etc. And then student model, it tracks students' progress, their knowledge status, or some misconceptions to help decide how to teach the students. And then the pedagogical model, based on student model and the domain model, the pedagogical model decides how to provide students feedback, like when to provide the students a new challenge, when to provide the explanation or the hints, etc. And then user interface, the last element. User interface basically facilitate the interaction between the system and the human and the students. So it includes like visual, auditory, or interactive elements to engage the students. Yes, so that's a brief introduction of ITS. And then one of the study I reported in last year's AI Ed conference is related to this ITS called 小麦. Just now, actually, I showed it a little bit. So it was developed by our team to provide students the help to learn advanced mathematics. Actually, there's another motivation is to prepare them.
یه کارا دارم میکنم روی درس دادن. خب چی میگی؟
Getting bigger, it shows that the competition is more intense. So it becomes more difficult for the students to get into the graduate school. However, for engineering and the science students, math is a very important subject for the entrance exam. And a lot of students, they just failed this exam. So it also motivates us to develop this ITS to prepare the students for the entrance exam. And then just now we talk about the importance of domain model for the ITS. So here is some information about 小麦. So 小麦covered all the three main subjects in advanced math. And then it includes 177 knowledge components, and there are around 5,000 questions in the question bank. And here, the two pictures are about the domain model. In the knowledge relation tree, we can see the relation between topics, sections, knowledge components, and the questions. They're well mapped to each other. And then in the knowledge component prerequisite map, we can see which components are the prerequisite of which. So that when students, they finish learning some knowledge components, we know how to recommend the following knowledge components to them. So this is the domain model of 小麦. And then just now we mentioned the key for ITS is to provide the students individualized or personalized learning. Therefore, the recommendation is very important. We want to recommend different students the appropriate learning materials for them. And for this system, we built in this system, the recommendation system is based on two algorithms. One is rule-based, the other is knowledge tracing algorithm. The rule-based algorithm, those rules were based on prior research. So this part of algorithm can deal with the cold start. That means when students initially get into the system, we do not have any information about the students. And then how do we recommend? So we follow this set of rules to provide the students the practice. And then when students start to interact with the students, we gradually collect students' data, right? The students' interaction are recorded by the system. And then we start to get more and more students' data. And based on students' performance in the system, the knowledge tracing algorithm start to work. They analyze students' data and decide, okay, how well the students have mastered some knowledge components and decide what to recommend next. Yes, so this is a recommendation system related to student model. As to our study, we didn't focus on the recommender system or domain model. Instead, we focus on two design features, which we think are unique to Xiaomai. And the first one is free response questions. So maybe we think free response questions is very normal, right? It's everywhere. But for math ITS, it's very rare. So far, most math ITS, we only implement multiple choice question. Why? Because ITS need to automatically evaluate students' performance. So for multiple choice, it's very easy. We just match students' choice with the correct answers. And then we can decide whether the answer is correct or wrong. But for free response questions, right now we need to recognize students' answer. For recognition of those mathematical notations itself is very hard. The parsing itself is hard. And then for free response questions, it includes many steps. And then how to categorize the students' answers, how to decide which type of error students made. That is also very challenging right now. So that is why it's rarely implemented into the math ITS. However, free response questions is a large part of the graduate school math entrance exam. So we still want to provide students proper practice, make them practice in our system. So what's our solution? Our solution is first, here is the free response question. And then we ask students to write their answers on scratch paper. And then after that, they're asked to take pictures. So everybody right now, we carry our phone. Yeah, they take pictures of their solution. And then by clicking on, click there, the picture, and then they get a QR code. And then they scan the QR code, they're able to upload the pictures containing their solutions. And after that, upon students' submission, our system provides the students the correct answers. And then the students were asked to self-evaluate their answers based on the provided solutions. So here is students are still evaluated, but it's self-evaluation. So this is, we think, is a creative design of this system. This is free response questions. And the second feature we evaluated in our study is related to error reflection. So it's one of the metacognitive elements we implemented in Xiaomai system. So for error reflection, it takes place only when an error occurs. So when a student made a mistake, we ask the students, the system asks students to select the reasons for the error from a provided list, including those types, like misunderstanding, calculation error, lack of knowledge, forgetting the knowledge components, carelessness, lack of problem solving. And they can also type in the reasons they think that is not listed there. So for that study, for the study we presented in AI Ed, it specifically evaluated the two design features, which are item format and error reflection. These are the research question was, to what extent do item format and error reflection affect students' performance and the learning outcome? So the item format is the comparison between multiple choice question versus free response question. And the error reflection is with or without error reflection. And then to compare students' performance here, the dependent variables, there are two. One is performance, the other is learning outcome. Performance refers to students' performance in Xiaomai system. It's like overall their accuracy, as how the proportion of correct answers. And also we evaluate the time they answer the question. And then for the learning outcome, we compare the pre-test to post-test learning game, pre-test to post-test learning game. And here it shows the research design, the experimental design. So students took a pre-test before the intervention, before the experiment, and the post-test after the intervention. And in between. For both pre-test and post-test, there are 18 multiple choice questions. And the questions were selected by the domain experts. We specifically controlled we make sure they cover the same knowledge components and they're of the same difficulty level. Of course, this is controlled by the domain experts to guarantee the content equivalency. And then during the practice, students were randomly assigned to one of the 4 conditions. So MC stands for multiple choice and FR stands for free response questions. So here we can see the difference between 1 and 2, as well as 3 and 4 are with or without reflection, right? 1 without reflection, 2nd half. But the students practice the same type of items. And 3 and 4 also the same type of item without or with reflection. And then if we look at 1 and 3, the difference is item difference, with or without free response questions. And as well as 2 and 4 is the same difference. So with this design, we can investigate the two variables. Yeah. So now let's see what we found. So for the item format, we found that students in the MC multiple choice only condition, they performed better during the practice. And they also achieved greater learning gains. So this indicates the free response questions didn't help, right? So it posed a big problem. Do we still need to keep the free response question in the system? And then regarding the reflection, it was, yes, surprisingly, it was not what we expected. The reflection had no significant effect on students' learning gains or performance. Based on the previous literature, we really hope, it's like our expectation was if the students in those conditions with reflection perform better. So regarding the findings, we try to explain our findings. So the first, students in MC only condition, multiple choice only condition perform better. Our explanation, one of the explanation is that the questions in both pre-test and post-test were only in multiple choice format. In the pre and the post, we didn't have the free response format. And there were literature indicating that the students only benefited from the same format type of questions they practiced. So students in multiple choice questions, they get more chances. They practice more on multiple choice question. As a result, they perform better. The students in like both items condition, they get less chance to practice the multiple choice question. That's the one explanation. And then regarding the reflection, our only explanation is that students may not engage in serious reflection. So students were asked to evaluate why you made the mistake. Probably they just choose some random reason. They didn't really reflect on why they made the mistake. And since it is an ITS, students were not monitored. We didn't have any mechanism to make sure students engage in serious reflection. And regarding this reflection, we wanted to collect more information, more data to explain this. Currently, we didn't have students, we didn't have the data to understand how students process, how students reflect. But for the next step, I think we can try to monitor the time students spend on reflection, to separate the time students work on the problems and they reflect. They did their ever reflection. Probably it will give us some explanation of why this happened. Okay, this is the study of, and it's important to note that just now we talk about the challenge of implementing free response questions in ITS, right? But right now, with the development of LLM, large language model, like the newest version of ChatGPT and the DeepSeek, they're quite good at evaluating the free response questions. And I think there are some data showing the accuracy could go up to like 70–80%. So right now our team actually we're working on implementing a large language model in Xiaomai to help evaluate free response questions. And once it's implemented, our system can provide. Yes, it's not letting the students to self-evaluate their response. Instead, is to provide automatic evaluation by the system. Yeah. And then that one, just now the system was built by my current institute. My team is the current institute. Now I'm gonna switch to another ITS, which is a conversation-based ITS called Auto Tutor. Here, so here. It's mainly related to my PhD study when I was in the University of Memphis. So Auto Tutor is a conversation-based ITS. It implemented the conversational agents to interact with the students. So basically, students can talk to the agents. And Auto Tutor include different versions. So we call it Auto Tutor family. Many versions have been developed to cover different topics like reading comprehension, computer literacy, physics, critical thinking, etc. And then the previous research has shown the learning gains of 0.4 to 0.5 standard deviation. And then the version of ITS I have mainly worked on is called CISO Auto Tutor. And this Auto Tutor was designed to help adult learners with low literacy skills to improve their reading comprehension skills. And here, as is shown in the picture, there are two agents. There are two agents implemented in this system. One is a teacher agent, the other is a peer agent. So the students can interact, can learn through interacting with the agents, as well as learning by observing the agents having conversations between them. Yeah. And then one of the studies indicated that CISO Auto Tutor effectively help adult readers improve their learning skill. So in addition to evaluating the efficacy, whether it can help the learners effectively, we also did some data mining work. So the data mining work is based on the learning logs that was recorded by the system. So when students log into our system and having conversations with the system, all the data were automatically recorded by the Auto Tutor. And then we extracted the log files, and using the log file to try to find the students' learning behaviors, try to categorize learning behaviors. So using the log files, we did this analysis is a clustering analysis. So we try to cluster students' learning behaviors. So here regarding learning behavior, it mainly refers to students' interaction time, so their response time, and the answer correctness. So in these two pictures, it shows four types of learners we have found based on students' interaction with Auto Tutor. The picture at the top is their response time. The picture at the bottom is the proportion accuracy. And then we labeled the four types of learners as high performers. Here we can see we label them as high performer because they spend very little time. The time they spend on different types of tasks were short. And then the accuracy on all those tasks were very high. So they're fast, but accurate. We label them as higher performer. And then conscientious readers, they spend pretty long time on different type of tasks, but they also reach comparatively high accuracy. So this type of readers, they're pretty conscientious. And then the third type, we call them under-engaged readers. They work fast. The response time were short. However, their accuracy were not that high, or on the lower end. So we call them under-engaged readers. And the last type is struggling readers. They spend comparatively long time on all the tasks, but the accuracy rate was low. Yeah. So by categorizing the students into different types, it helps us decide how to improve our system to adapt to different students' needs. For example, after categorizing different type of students, we can give them different type of tasks, or at different times provide them different intervention. And another study was also based on the log files, and the log files. And we also look at the students' response time and accuracy. And then we developed another algorithm to track students' engagement. And this picture showing the algorithm that was built to detect or track students' engagement. And using this algorithm, once the students was detected as being disengaged, the system, we can build up something like a pop-up window to remind the students, do you need a break? Yeah, or if the students, they're struggling, they keep making mistakes, and meanwhile, that made them disengaged, we may consider adjust the learning materials difficulty level, or change their learning path. Okay, so those are the research related to ITS. Now I'm gonna move on to the educational games I've worked on. And educational games are also referred to as game-based ITS. And this thread of work was mainly done during my postdoc in Arizona State University. So the two main game-based learning environments I've worked on are called iStart and Writing Pal. So iStart is a game-based ITS to help students improve reading skill. And then Writing Pal was designed to provide the students writing strategy, instruction, and training. One for reading, one for writing. In one study, we examined the perform-based assessment. So basically, we want to see whether the students' performance in a game can reflect their literacy skills or their reading skills. And then we used this game, which is a vocabulary game, or very short, only 5 minutes. And it's very simple. Basically, students only need to select or asked to select the synonyms of the given words. And meanwhile, this game is an adaptive game. That means students can level up or level down based on their performance. And in this study, we found besides playing the game, the students in our experiment, we also asked the students to take a survey, asking them about whether they like the game enjoyment. And also, of course, we want to predict students' literacy skills. So students took the standardized, well-established standardized literacy assessments. So basically, we want to use their performance in the game to predict the results of their literacy assessments. And then we found that students enjoy enjoying this game. And then also, this short game can be used to assess students' literacy skills. And then inspired by this study, we add more games from iStart. Into a further experiment. And then we added Adventurous Loot and the Dungeon Escape. These two games into the further study. Adventurous Loot asks students to select the main ideas. And then Dungeon Escape is about the topic sentence. And then the design of the study was basically the same as the previous study, but we just added more games. Our goal was still to predict students' literacy skills using students' game performance. And then we found that each individual game can be used can be used to assess students' reading skills. However, the combined performance across the game, they are better predictors. So even if students play the 3 games, it's around like 15 minutes. They're all short games, but then within 15 minutes, we can evaluate students' reading skills. So if we take this approach instead of the traditional approach, compare this approach with traditional approach, probably students would prefer this approach, because in traditional testing, students need to pause their learning, go to take a test. Their learning is interrupted. And meanwhile, some students, they're scared by the text. Some students, they suffer the text anxiety, right, which is a theory in psychology. But by using the game, the players are playing the games, and meanwhile, they didn't even notice that they are being assessed. However, we can assess them unobtrusively or stealthily. That's why this type of assessment is also referred to as stealthy assessment, stealth assessment. And then just now the 3 games we saw, they all let students like choose the correct answer. So basically there are multiple choice questions are implemented in those games. However, in iStart, in addition to those type of games, we also have games ask the students to generate their texts. So it's like students are asked to paraphrase the highlighted sentences. They need to type their answers. And therefore, with this type of data, we explored the natural language processing, the NLP methods. So we collect the text generated by the students, and then we analyze the text, extracted the linguistic features, and do feature selection, and build predictive models of students' literacy skills. So we explored different approach to assess students' literacy skills. Now that you may ask, why is literacy assessment important for this game-based environment for iStart? Why is it important? To briefly speaking, it is used for macro level adaptivity. Specifically, so for each game, we have the built-in algorithm to decide how to adapt. It's like, what's the next word to provide to the students, right? Based on students' performance in games, within this game. Those are task-specific assessment. However, in iStart, we try to provide students training of different strategies. For example, we have one module focused on paraphrasing, another module focused on question asking. And then students' answers or their performance from paraphrasing may not indicate whether they're good at ask questions or not. So we need more like task general assessment to give us the information to decide where to branch to how to guide the students. After the students perform to this level to some level in the paraphrasing module, where should we take the students? So we rely on the literacy assessment to give us this information to decide how to do the macro level. So it's how to do the macro level adaptivity, which means the adaptivity between the modules. In addition to developing and assessing the games, I also led the design of some new games. So mainly some game, we want the game to be more engaging, to look better. So we try to develop interesting storyline and more interactive interface to make the players really feel they're playing the games. So this is one of the games we designed. We can see from the title, Paraphrase Sleuth. So basically the main task is for the students to do the paraphrase, to paraphrase. But then we situate it into the storyline that a crime happened and the students, everybody starts as the rookie detective. They need to collect the evidence to help solve the crime. And then the way to solve the crime, collecting the evidence, is answer some questions, paraphrase questions. So if they answer the questions good enough, they can help solve the case, to close the case and get promoted. If they do not perform well enough, the case may remain a botched case or the cold case, and then students are suggested to get more training. Okay, those are the work I have done related to the educational games or game-based ITS or serious games. They're all the same. And then in the end, the last part of my talk is about application of generative AI in instruction, which is a big trend now. And a lot of research are shifted to generative AI or LLM, large language model, right? The first study is a collaboration with Professor Brubaker here. So we explored the application of large language model in CS instruction. So the main goal is to generate the free response challenging questions to help evaluate students' understanding and diagnose the plagiarism. Because right now we know for CS, if you ask ChatGPT to generate some code, he quickly generates the code for the students. So if Professor Brubaker give his students some homework, they may purely rely on ChatGPT to finish the homework. And then we want to see whether they are able we want to see whether they really understand the codes, or to see whether they just completely, like the plagiarism, completely rely on large language model or AI to get the answer. So we try to generate, we need some challenging questions to help detect this. Here it shows it shows the study, the study. So first, we use students submitted code. Students submitted code and then inject some code with untaught concept into students' code. And that's the code for analysis. And then we use the selection algorithm with the help of large language model to select the candidate code, which means the code with untaught functions in it. And then the selection algorithms work pretty well. We get 33% accuracy. 73, I'm sorry, 73 accuracy. And then using the candidate code with untaught functions, we took the RAG-based approach. So basically we ask LLM to generate the challenging questions, but we provide them the course-related materials. So that's a RAG-based approach, and then to generate the challenging questions. We evaluated the large AI-generated questions using the rubrics, including the 3 dimensions: relevance, clarity, and depth. We can see the AI-generated question did a good job. Yes, so we can use the AI-generated challenging questions to check students' understanding and for the diagnosis of plagiarism. And then the other project right now is ongoing. Is the AI-generated feedback for ESL instruction, English as a second language instruction. Is happening in CCNU right now because we're all ESL, second language speaker. So here, Professor Brubaker helped us build this this platform, which we give it a name that's called Essay Master. Yeah. So Essay Master, in this platform, ChatGPT is implemented, and it provides students feedback based on the rubrics that has been implemented, the rubrics that is provided by the course instructors. And in the last semester, we conducted 2 experiments in 2 courses, which are English writing, college English writing, and critical reading. And all the students are ESL learners. One course focus on help students improve their English writing skill. The other focus on improve students' critical thinking skill. So the general experiment design is that both experiments last a whole semester, which is 16 weeks. And then students were assigned to 2 conditions. One is AI-generated feedback. The other is peer feedback condition. So in both courses, the students, they were required to submit their writings, and then the writing, they either get the feedback from Essay Master or get the feedback from their peers, student peers. And at the beginning of the end of the semester, students took pre-test and post-test to test their writing skill, or the other course, their critical thinking skills. So we want to see the learning games regarding the improvement of those skills. And meanwhile, they also took the surveys on their writing self-efficacy, whether they enjoy writing enjoyment, and also feedback literacy. And then the major finding for both courses, we found that AI feedback is comparable to the peer feedback regarding students' improvement in writing or their critical thinking skills. Or in other words, there's no significant difference between the 2 conditions. So usually non-significance is regarded as not good. However, we're quite happy with these results because AI is comparable. Yes, we really did not expect it to outperform the humans. So comparable is satisfying for us. And then here I put 2 pictures. I put 2 pictures from the results in the critical thinking course. So here, the blue bars and the orange bars stand for the peer feedback group and AI feedback group. The 3 measures, interpretation, evaluation, and judgment, there are 3 critical thinking measures. So on all the 3 measures, we found actually here the effect size for the AI feedback group are slightly higher than the peer feedback group. However, with statistical analysis, we didn't find a significant difference between the 2 groups. So they're comparable. And another interesting finding is regarding students' feedback literacy. So here, appreciating feedback is one dimension in students' feedback literacy. And when we look at students' English proficiency, took a look at student English proficiency, we divide students into high and low group. The students with better English skill or students with worse English skill. And then we found the students with higher English skill, they appreciate here. The blue line stands for we say control. The blue line are the peer feedback group. And then the green line is the AI feedback group. So if we look at the high group, students with high English proficiency, we found that they prefer AI feedback over the peer feedback. However, for students with low English proficiency, they prefer, it's another way around. They prefer the peer feedback over the AI feedback. Actually, this tell the teachers, the instructors, how to do the personalized instruction, right? So we may make the students with higher English proficiency just use AI more, right? Give them personalized instruction. And our explanation for this finding is probably students with higher, because usually ChatGPT, the feedback from ChatGPT is complicated. It's well written, but more complicated. And the peer, for the student peers, especially second language student peers, probably they use more simple language. So when my language skill is lower, I prefer the simpler language. And if I can understand very sophisticated language, probably I prefer the language that's similar to mine with more information. Yeah. So the overall implication is that since AI is comparable to peer feedback, we can use AI-empowered tools in English writing in those both courses for effective and efficient instruction. But here we do not think we should use this to take place of the peer feedback, because peer feedback, one of the advantage is we have interpersonal communication. Yeah, that is engaging. So if the both methods can be used, can be combined to use properly, it will promote the learning even better. Yes, so that's all for my presentation. Merci de votre attention.